So, we're doing some strange titles because we're stepping away from the book for a little bit. Okay, so this is the third section, 5.3. We're actually doing technically 5.3 and 5.4 today. But it's called It's All in Your Head. Now, the central question are, what are the 4 different types of proofs, and which is your favorite and why? We've already done one style of proofs, when we did the UNO proofs. Does anyone remember how we laid out our proof? Like, what format did we lay it out in? Torrance? A THR, a 2-column proof. Okay, so that's one style of proof. And today, we're going to be focusing on another style of proof, and I'll tell you the names of a couple others. Okay, let's see here. Oh, but before we get going, I need to go over some vocabulary. Okay, what is a median? Anyone know? A median of a triangle. Okay, we know median means middle. Like if we had data, it would be the middle number when they're ordered. Median of a triangle. Okay, so the formal definition for median of a triangle, let me get it right here. Oh, there it is. Okay, a segment whose endpoints are a vertex of a triangle. A segment whose endpoints are a vertex of the triangle. That's one of the endpoints, is on the vertex of the triangle. Okay, and the other endpoint is the midpoint of the opposite side. So when you said middle, it extends to the midpoint of the opposite side. And the midpoint of the opposite side. A segment whose endpoints are the vertex of a triangle and the midpoint of the opposite side. Okay, we're going to need some tools for today, so can I get a volunteer to pass out a ruler to everyone? Okay, Vanessa, and you know how these compasses are. I doubt we have enough working ones for everyone, so you'll have to share. Okay, I'm just going to give about 4 to each row and see how we do. And you'll have to share with the neighbor. We're not using these too much, so it's not a big deal that we're sharing. But these compasses are just breaking left and right. So please be careful with them. Already running out. Okay, so pretty much give 1 to every other person. Spread them out, 1 to every other person. If you have, didn't someone over here have their own last time? Oh, that's right. Maybe this one will work. Let's see. Yeah, that's a good one. Okay. Pass these out. We won't need the compasses until a little later, so just put them on the side. But I would like you to take the ruler. Hey, you can just give the rulers to the front of the rows. Vanessa, just count them out and give it to the person in front, and they can pass them back. It'll be a little faster. But thank you. Okay, with the rulers, would you draw a triangle? I'm going to choose to draw a scalene triangle so we can really understand what a median is. Scalene triangle means all 3 sides are a different length. Thank you. Triangle ABC. Okay, this triangle needs to be like a medium size, large enough that we can actually draw inside of it and label inside of it, but it doesn't have to be enormous. Okay, say we were to drop a median from vertex B. Michael, do you have paper? You should be writing on the paper, not the clay, or whatever that is. Okay, if we were to drop a median from vertex B, it needs to extend to the opposite side and intersect at the midpoint of the opposite side. Okay, so actually we need to construct that midpoint really quick. So taking a compass, and then you'll have to pass the compass back and share because we don't have enough. The compasses, you notice we're going to be using compasses in our homework. They're really only like $1.25, I think I saw at the grocery store the other day. So it might be a good idea to invest in one. Otherwise, you can always take a pencil and tie a string on it. Okay? If we need a midpoint of AC, we need to bisect it. And we've learned how to bisect already. Okay, so put the sharp point on A. And you need to spread it widthwise, wider, more than halfway. More than halfway. There we go. More than halfway. And don't go all the way to C. You don't need to go all the way over. More than halfway, and draw a semicircle, an arc. Pick it up. Move the sharp point over to the other end point, which is C. And keep the width the same. That's key. You have to keep the width the same. And then you just need another arc that intersects the first arc twice. Once you've done those two arcs, pass your compass back to another person. More than halfway. The reason you have to go more than halfway is because that will allow it to intersect. The two arcs will intersect if you go more than halfway. Like, I have one more compass here that seems like it's a good one. I think this side was short. Let me pass that back. Okay, once you're done with the two arcs, pass the compass back. Then you line up your ruler. Oh, look at that. That's kind of cool. You line up your ruler so that, I don't know how to rotate this. Nope. Okay, well, I'm not going to use that ruler because I can't figure out how to rotate it. Well, I see this, but it only makes it bigger and smaller. Here's some green dots. Anyway, line up your ruler, and we don't need a straight line through it. What we need is, if you line it up here and here, we just need the intersection on AC. And then if you connect B and extend it out to that intersection, that's the midpoint of AC, we've just constructed the median. We just constructed the median. Okay. Next vocabulary word is altitude. We've talked about altitude before. Oops. Altitude of a triangle. If you recall the lesson where we took a triangle and we rotated it twice, and we don't draw these triangles, I'm just going to revisit what we've done before, so you don't have to draw these triangles. We rotated about its midpoint, and we noticed when we rotated it once, what did it form? It is a quadrilateral, and what type of quadrilateral? A parallelogram. And we knew that they were parallel because we showed information about altitudes. Altitude is the height of the triangle. And do you remember an altitude intersects the floor or the ceiling? It has to intersect at a certain degree. Altitudes intersect at what degree? A what? 90 degrees. It's perpendicular, intersects at 90 degrees. The only way these two lines can be parallel, and we can show parallel by doing like a double arrow, that would be marking for parallel. The only way those would be parallel is if their supporting beams are congruent, right? Their altitudes would have to be congruent in order for it to be parallel. If one of the supporting beams was shorter, the room would be lopsided. Your ceiling would have sloped down on one side. Okay, so the formal definition of altitude of a triangle is, okay, the perpendicular segment from a vertex of a triangle, the perpendicular segment, from a vertex of a triangle to the opposite side. A triangle. Oh goodness, I missed vertex. Let's try that again. Perpendicular segment from the vertex of a triangle to the opposite side, or to the line that contains the opposite side. To the line that contains the opposite side. I'll tell you what that means in just a sec. The perpendicular segment from the vertex of a triangle, just like the median, starts at the vertex. It's going to extend to the opposite side, or a line that contains the opposite side. So we're going to do two triangles on this one. The first triangle I'd like you to draw is an acute triangle. So take your ruler and construct an acute triangle that has, a medium size that we can work with, and we're going to construct a perpendicular altitude. I'll show you how to do that. So if we label it A, B, C, and we want to know the altitude of this triangle, we'd have to start at vertex B and drop a perpendicular. But it has to intersect at 90 degrees. So we need to learn how to construct one of those that intersects at 90 degrees. So I'll give you a sec to draw your triangle. Okay. If you have the compass right now, take your compass. We're just going to do 3 arcs, and then you can pass the compass to the neighbor. So if you don't have the compass right now, just try to follow along so you know how to do this when you get the compass. The first thing you need to do is put the sharp point on your vertex you want to start with. I'm going to start with vertex B and drop the altitude down from vertex B. Jamie, the phone is going in your bag. Okay, we need to draw an arc that will intersect AC twice. And so it's okay if your arc, see if I draw my arc there, I actually missed a side, that's fine. Well, all we have to do if you miss the side, and I can extend it out more and completely miss the side, all you have to do is take your ruler, let's go to the other side, and extend AC, and then we're just looking for those 2 intersections. Okay, right here is an intersection, and right here is an intersection. So if you don't quite intersect twice, that's okay. You can just extend the line like I did. Okay, now keeping the same width, we're going to take the sharp point and put it on one of those intersections. Keeping the same width, I'm going to pick up the compass and put at one of those intersections, and below the triangle, I'm going to draw an arc out here. Then I pick it up again, and I'm going to actually flip it around and put my sharp point on the other intersection and draw a third arc down below that intersects the second arc, like that. If you've done that, then please pass your compass to your neighbor. So, again, I put the sharp point, here I'll show you. Put the sharp point right here on B, and I draw my arc that intersects twice, okay? Mark those two intersection points. Then you take the compass and you put the sharp edge on one of those intersection points. Okay, and you draw, well, you'll eventually do both. And then you move it over to the second one, just long enough that you can see where they are going to cross. I need it coming down. There we go. The idea is we have to see where those two arcs cross. Okay, then line up your ruler from point the vertex B to this intersection of the two arcs. Okay, I'm going to use my real ruler, not a smart board ruler. Okay, and then you're going to draw a line. I don't know if it will, oops, that didn't work. Okay, I thought my ruler was an eraser, I don't want that. You're going to draw a line from the vertex down to the triangle. You don't have to go through the triangle. And what you've done there is constructed a 90-degree angle, so put the box. Who needs help? Okay, we're going to do another one because I said altitude of triangle goes from a vertex to the opposite side, like we've shown in this triangle, or to a line that contains the opposite side. That happens when we have an obtuse triangle. Okay, so we're going to do this construction again, but we're going to show how to do it on an obtuse triangle. Okay, so I'm going to draw an obtuse triangle, like so. I actually think I want to move mine over. You need some room on the left, so don't put it too close. Oops. Okay. Scooch. I need some room on the left. Because if you look at, if this is A, B, and C, the height of the triangle is not this distance. How would we measure the height of the triangle? This way? From C? Okay, yes, we could go from C, but then where would we stop? What? When we're even with B. Yep. Or another option, which is kind of the same idea of the, oh wow, I'm going to have to push undo a lot to get rid of those. There we go. If we extend, like the definition says, a line that contains the opposite side. If we take AC and extend it out, then we could drop B, right? Okay, so we're going to construct that. So if you would please extend out the line AC, we need to construct the 90-degree angle. It uses the same three steps that we did on the last triangle where we constructed an altitude. Our starting vertex is again on B. So put your sharp edge on B. This arc we're going to draw needs to cross twice on the opposite side. Our opposite side is AC, and we've extended it, which is fine. It needs to cross, oh, well, so I totally missed mine. I guess maybe I should make it a little smaller. Let's try that a little smaller. Or I need to extend my line a little bit. Yep, looks like I need to extend my line. Okay, that's all right. Okay, it's not letting me do that. All right, well, I'm just going to draw this first, and then I'm going to fix my line. There we go. Now I can actually see the intersection. So I had to extend my line a little bit. That's okay. Has everyone gotten to that point? Okay. I'm going to take that stress ball. Please put it away.
What?
Whatever that is, stress ball or clay, whatever it is, it needs to be put away. In your bag right now. Thank you. Okay, then you mark the two intersections. I have an intersection here and an intersection here. Those are the 2 points where you put your compass on again. Okay, so I lift up my compass. Whoops. So I messed up my width. If you do that, just reposition it. Make sure the width is correct. Oh, I messed it up again. What's going on? There we go. Okay, put it on one of those endpoints or the intersections. And below, we need an arc. Move it to the other intersection. And I'm going to rotate this down a little bit. We just need the third arc to intersect the second arc. If you've done that, please give the ruler to your neighbor, or the compass to your neighbor. Okay, you just line up your ruler from B to that intersection and drop the perpendicular. That creates the altitude, which is like the height of the triangle. Please make sure you've passed back the compasses so everyone has a chance to construct. If you need help, raise your hand or ask your neighbor who's figured it out. You doing okay? Make sure you draw in the 90-degree square. Okay, you have the first step. Let's finish it. This one's kind of wobbly. Can we use that one? Thanks. So you have the first step, so we're just going to adjust this one. Okay? So now you need to put the pointy end right here, and then we'll move it to there. And draw an arc down below. Okay, good. And now put it there and draw another arc that should intersect your second arc. Good. Yep, we just need that intersection point. So now you line up your ruler from the original vertex to that point you just made. And you draw a line just in the triangle. You don't have to go through the triangle. And then end it with a 90-degree angle. Okay? Good. Now do it a second time with an obtuse triangle. All right. I think looks like we're pretty much ready. Do you need help? Ready to move on. Okay, a couple more vocabulary words which don't require construction, so they're not going to take like the whole side of the page like we just used. We have this abbreviation that when we do proofs, we always have to have a reason why we're allowed to say that. For instance, in Uno, if a blue 5 is shown and I have a yellow 5, how come I'm allowed to play a yellow 5 on top of a blue 5? Because the number, the face matches. So, yeah, because we did Uno proofs earlier, a few days ago. Okay, so there has to be a reason or a rule why that works. One of ours is called CPCTC. Everyone say that. CPCTC. Everyone say it. CPCTC. It's kind of a tongue twister if you say it. Yeah. Okay, it stands for corresponding parts of congruent triangles are congruent. Please write that down. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. once we know two triangles are congruent, then they have matching pieces that are congruent to each other. And those are called the corresponding parts. And the abbreviation is CPCTC. Okay, another definition is the reflexive property. The reflexive property. Get over here to my page. Okay, the reflexive property is every triangle is congruent to itself. Okay? Every triangle is congruent to itself. Every side of the triangle is also congruent to itself. So anything is congruent to itself. Every triangle is congruent to itself. That's the reflexive property. The transitive, actually let's do symmetric first. The symmetric property the symmetric property says if triangle ABC is congruent to triangle DEF, then the reverse is also true. We could say triangle DEF, start with the second one, is congruent to triangle ABC. Okay? So symmetric property says if we know it's congruent in one order, if we reverse the order of how we state it, it's still congruent. Does that make sense? And the last one is the transitive property. Transitive property, okay. So raise a hand, who in here is 16 years old? Put it up high. 16, okay, I need a few. Alejandro and Myra and Braden. Okay, hands down. So, Alejandro is 16. Alejandro, listen please. Shh. Alejandro is the same age as Myra. And Myra is the same age as Braden. So, what does that tell you about Alejandro and Braden? No, what does it tell you? Alejandro and Braden are also the same age, which we know is now 16. Okay, so the transitive property is if the first equals the second and the second equals the third, then we know the first equals the third. Through like deductive reasoning, right? So transitive property. If triangle ABC is congruent to triangle DEF, oops, I didn't write the triangle. Let's try that again. Okay, and triangle DEF is also congruent with triangle JKL. Notice these are all capital letters, okay? In geometry, when we're naming points, vertices, or segments, we use capital letters. In algebra, we use lowercase letters for variables. Okay, so this is Alejandro is the same. Did I spell your name right? Alejandro. Okay, is congruent with Myra. Myra, did I spell your name right? Yeah. And we know Myra is congruent in age to Braden. Okay, Braden. A-E? D-O-N? Okay. Then, if triangle ABC is congruent to triangle DEF and triangle DEF is also congruent to triangle JKL, what can we conclude? Yep, so Alejandro is ABC, Braden is JKL, so ABC is congruent to triangle JKL. Then, triangle ABC is congruent to triangle JKL. KL. This is the transitive property because we're proving things. So once we know two pieces are congruent and that second piece is congruent to the third, we can now conclude that the first was congruent to the third. So this is Alejandro, and this one was Braden. Ooh, barely made that in there. Okay. That's the end of the vocabulary. I'm going to play a short video. I'm going to be pausing it as it goes through. And I would like you to, the first example, we're just going to be mentally engaged, participating mentally. The second and third examples we're going to write down and do. Okay, this is introducing a new way to do proofs called the flow chart. Okay, would you mind hitting those lights in the back for me, please? Thank you. Okay, I'll play it when we're quiet. Please put your heads up. Lucas, I think you can't have that drink in here. Unless it's clear water, you can't have it. Unless you want to pay for the carpet cleaning costs or replacing the carpet. You can't have it. The rules of class are you may have water, and that is it. It does say on disclosure, and it's on my wall that there's actually no food and drink. The only one I allow is water that is clear with no sugars in it. It is in the disclosure, which is on my website if you don't believe me. Okay. This first one, we are going to just pay attention. Mentally engaged. I'd appreciate it if people were turning around, facing the board. Turn your whole body around, please.
Alright, so today we're going to conclude our lessons with proofs and triangles. We're going to talk about flowchart proofs, which are a tool to use. You can use a flowchart proof, or you could use a T-column proof, you could use a paragraph proof, or you can use a proof map. The flowchart is kind of a road map that shows the steps in a procedure, and they have to be done in a logical order, just like any other proof. Here's an example of a flowchart to do a procedure. I want to make a peanut butter and jelly sandwich. Alright? So the first thing I have to do is get all my materials. Now I can open the bag and open both the peanut butter and the jelly jar. Once I've done that, I can take 2 slices of bread out of the bread bag, put it on the counter or a plate or whatever. From the 2 jars, I can scoop what I need to. First, I'll scoop some peanut butter out and put it on 1 slice of bread. The question is, do I have enough? If I'm not happy, I'll go back and get some more peanut butter. If I am happy, I'm going to continue on. I'm going to scoop some jelly out and put it on the 2nd slice of bread. Do I have enough jelly? Well, if not, I can go back and get some more. But if yes, I'm going to put my sandwich together by putting the jelly side to the peanut butter side and smushing together. I can cut it in half and then start eating my jelly. Now, this is a complex diagram to do a pretty simple thing, but it does lay out how logically you have to do things in order.
Okay. So this is an example, not math related, but it's an example of a flow chart. Okay? There, you have to lay out the order. Can you first, let's see, can you first put the peanut butter on before you open the bag?
Oh.
Not if you plan to digest anything that's not plastic. If you put peanut butter on the bag, then you're going to be probably eating the bag too, which is kind of gross. Okay, so a flow chart lays out in order the steps, and it's very detailed, specific. First, you open the bag. If you want to keep mouthing off, you can leave. Okay, I don't appreciate it. First, you open the bag. Then you have to open the jars. You take the 2 slices and put it on the counter. Maybe one other step, if we were really going overboard, we'd say, get a knife out of the drawer. Okay, you scoop some peanut butter, but once you scoop some peanut butter, two situations could happen. Once you spread it on, is there enough peanut butter to your liking? If yes, continue on to the jelly. If no, then you go back into the jar and you get more peanut butter, right? There's two options. And once you can answer yes, then you continue on. Same with jelly. Once you can answer that you have enough, you can answer yes, then you continue on, put this sandwich together, slice it if you prefer, and enjoy it. So that's an example of a flow chart that's not math related. This next one is going to be a math one. I will pause it, and I would like you to, for example 1, put example 1 on your paper and copy down the diagram and the blank flow chart, okay? I'll pause it for you. Here we go. Copy that one down, please. This will be example 1. And these right here where it says, make sure you write down the given. Segment EC is congruent to segment AC. Segment ER is congruent to AR. And right here, that's an angle sign. Okay, I like to make my angle signs a little bit bigger, but that says angle E is congruent to angle A. Torrance? Yep, and the boxes. Was that your same question? Yep. Okay, example 1, copy down the diagram. Make sure you write down the given information and the boxes. Make sure the boxes are large enough that you can actually write in them. They don't have to be enormous, but you have to be able to put some words inside of them. No nonsense, just a few things. Okay, I'm going to play it, and just as she goes along, fill in what she fills in, and pay attention to the explanations.
A flowchart proof is pretty much the same thing. And it isn't any different from the proofs we've already done, except that it's laid out a little bit different. So let's start. I'm going to mark my proof with the given information. First part is EC and AC are the same.
So mark yours, please.
Then I'm going to mark that ER and AR are the same. Once I've done that, I can kind of see I have two sides of a triangle, and they do share this common side. So I'm going to say, I'm going to use that. So now I can start writing my proof. Once I've gotten that I can justify these two triangles being congruent, then I can make the case that the angles E and A are congruent by CPCTC.
Oh, we've heard CPCTC. Everyone say that again. CPCTC. Okay, one more time. CPCTC. Turn to your neighbor and tell them the words that CPCTC represents. It should be on your notes. Turn to your neighbor and tell them the words. The 5 words. Actually, I guess it's 7 with the conjunctions. Okay, let's hear from Ariana. What does CPCTC stand for?
Corresponding parts of congruent triangles.
Yes, good. Corresponding parts of congruent triangles are congruent. All right, that's something you need to know.
So my first step is to write down my given information.
Okay, fill in the first box with the first piece that was given.
EC is congruent to AC.
We do need the segment bars above.
ER. Whoops. ER is congruent to AR. And both of these are because those were given information.
So outside, next to the box, you write...
The other thing I then noticed was that I have RC is congruent to itself, which was our reflexive property.
Okay, remember, reflexive property, anything is congruent to itself. So she noticed that RC was the same segment. If it belonged to the first triangle or the bottom triangle, it didn't matter. It was the same segment. So RC is congruent to itself. And remember, that's the reflexive property. And yes, this does say AR right here. Okay. Reflexive property, RC is congruent to RC. So outside the boxes, you put the reasoning. Why can we play the yellow 5 on top of the blue 5? The reasoning is because they have matching 5s.
All these things together, let me say that my triangles, triangle RAC is congruent to triangle REC.
Can anyone tell us why? What? Those are triangles. Triangle RAC is congruent to triangle REC. And why? What's the reasoning that she's going to say? Why can we say that these two triangles are congruent? We have 4 congruency postulates. Can you pull out your triangle congruency foldable? RAC, REC. Pull out your triangle congruency foldable, please. I just gave my last one away yesterday. But it was red and pink. Here's the outside of it, at least. And then it had those pink or orange papers woven inside of it. Okay, pull it out, please. We have 4 triangle congruency postulates on that foldable. The 5th one is hypotenuse leg, but the one we need is on this foldable. How can she say that those triangles are congruent based off the markings? Which one is it? You have 4 on your foldable. Thanks for pointing out your foldables. Which one is it? Look at the markings. Are any of the markings on angles? No, none of the markings are angles. So how do we know that these two triangles are congruent? Side, 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 yes. Okay, keep that foldable out. We'll need that later.
Because of side, side, side congruence. The last thing we have is that the angles are congruent. Angle E congruent to angle A. And those are congruent because of corresponding parts.
See, okay, I know her writing's floppy. I'll say it. It says angle E. It's actually right here in blue. Angle E is congruent to angle A by CP/CTC. Because we knew the two triangles were congruent, then everything in the triangle is congruent. So the congruent parts, the corresponding parts of congruent triangles are congruent. Angle, she puts a slash through her angles. It's right here. Angle E is congruent to angle A. Okay? So this is mapping out step by step how we can get to what was requested and prove it. Okay, the next one we're going to work through together, but I'm going to show it to you first and copy it down, have the boxes ready so we can fill them in.
Alright, same idea as the 2-column proof or the proof map, just laid out a little bit different. Some people will like it, some will not. Let's do another.
Okay.
Here.
All right, please copy that down. Do you know what that is? I don't know what that means. Is it a reading book maybe in the library? No. I think it's just to tell you have a book on hold. Did you reserve it maybe?
Yeah.
Okay, so you can probably pick it up after school. Okay, this is example 2. Please copy it down. I'm going to freeze the screen.
I'm given that angle 1.
Sorry, I didn't mean to do that. Just one second. That's huge. Okay, what do you need?
Just Mara.
Yeah, Mara. Mara, would you raise your hand, please? Okay. That's the same problem. This is your example, too. Okay, let's go through it and see if we can figure it out, how the flow chart is set up. You can't have, is that just water? Okay, and this is a 1. I paused it when the marker was over it. That's angle 1. Okay, the first thing, if you recall the last problem, first thing she did was take the given information and mark it on the picture so you can visualize what's going on. So given, it says angle 1 is congruent to angle R. How do we mark congruent angles? With a what? Okay, we usually do slashes through the sides, so how does the angle look? A curve, an arc. You can put a slash through the arc, but at least we do an arc. So angle 1 and angle R are congruent, so put an arc to show they are congruent. Then it says angle 2 and angle N are congruent, but they're separately congruent. They're not congruent to the first, at least we're not told that. So angle 2 and N are another pair, so I'm going to do a double arc to distinguish that these two together are congruent. And then the single arc goes for angle 1 and angle R. What else were we given that we should mark on our diagram? What else are we given? Yeah, MR is congruent to segment MN. So segments, we put slash marks, little tick marks. So MR is right here. This is congruent to MN. We're trying to prove the next part. So we don't actually mark KR and PN, but we're trying to prove that the top segment, KR, is congruent to the bottom segment, PN, or NP. Okay? So, in the first few boxes, we now write out the given information. The first things given were angle 1 is congruent to angle R. Angle 1 is congruent to angle R. The next thing that was given was angle 2 was congruent to angle N. And then what's the reasoning that we can say that those are congruent? Yeah, given. So we just put between them that these were given. Okay. Let's think about this. If we know these two in red are congruent, and these two are green are congruent, is there anything we observe that we could continue with our proof to show that the top segment, KR, of the top triangle is congruent to the bottom segment, NP, of the bottom triangle? Proofs take some thought, so I want you to be mentally engaged. Look at the picture, please. Based off of the markings, we have angle 1 and R are congruent. We mark that in red. Angle N and angle 2 are congruent. We mark that in green. What? What did you say, Michael? What did you say? K, what do we know about angle K and P? We could go that path. What do you know about angles K and P? How would we know that they were congruent? We have a theorem we've learned about angles of triangles that would prove that those were congruent.
Draw a circle on it.
No, we don't draw a circle on it. Don't you remember when we took a triangle and we ripped all three angles off and then we put them together What did we learn about 3 angles of a triangle? They add up to 180. Okay, we could say, this is one direction we could go, is that angle K and angle P are congruent because of, that's called the triangle angle sum theorem. If we actually technically we cannot say that yet because we have no congruent angles between the top one and the bottom one, the bottom triangle. Can we say anything about the relationship from the top triangle to the bottom triangle? Zach, please put the ruler down. Do not spin those. What? Oh, what do we know about angle 1 and angle 2? It was on your test that we just had. Angle 1 and angle 2 are what type of angles? There we go. Vertical angles. What do we know about vertical angles? Vertical angles are congruent. Okay, so angle 1 is congruent to angle 2. I'm just going to put a slash. So let's write that. Angle 1 is congruent to angle 2. We know that because they are vertical angles. Now we finally have a connection between the two triangles. If we know that their vertical angles are congruent, but originally I'm going to put this back to the original. Originally 1 and R were congruent, and 2 and N were congruent, and now we know the vertical angles are congruent. How does that start a chain reaction? Mara? Ah, good. It shows that angle N and angle R are also congruent. How can we say that, Mara? Mara, sorry. How can we say that? Yep, the transitive property. If Alejandro is the same age as Myra, and Myra is the same age as Braden, then we can conclude that Alejandro is the same age as Braden. That's the transitive property. So now we know all of these angles are congruent to each other. All 4 are congruent. So we have angle, let's see, angle N is congruent to angle R by the transitive property. Okay, there's actually one more piece of given information we never wrote down yet. Let's write that down. Segment MR is congruent to segment MN. Again, that was given. Actually, you know what? I'm thinking, I'm actually going to put the transitive one right here just because of how they set it up. Transitive property. Okay. Because now that we have 2 angles have corresponding congruent angles on the other triangle, and the segment that's marked is also congruent. Look at where the marking is. We have triangle congruence theorems, or postulates I should say, on your foldable. There are 4 of them. Which one helps us right now? Side angle side. Are you sure? Which one's sandwich, the S or the A? I have angles on the outside, and I have what in the middle? Side. So it would be angle, side, angle. So we can now say that the 2 triangles are congruent. Triangle NMP is congruent to triangle. Now be very careful in the second part. The first one you can put in any order. The second one, though, has to have congruent or corresponding parts. N. N corresponds to which angle on the top triangle? It corresponds to R. So we'd start with R. M corresponds to which triangle or which angle on the top triangle? It's also M. Yeah, M corresponds to the other M. Okay, and P corresponds to which angle? Okay, that's important. The first one you can do in any order. Sometimes we like to do an alphabetical order, but the second one has to match order. Okay, and we know this by, what's the postulate from our foldable again? Angle, side, angle. Okay, and because we know now we have two congruent triangles, what can we say about the base, segment NP, and the top here, segment KR? They're actually congruent by, we learned this one today. What allows them to be congruent? What do we write on the front side of your notes for vocabulary? CP, how does it go? CP, CTC. These are congruent by CP, CTC. CP, CTC. Corresponding parts of congruent triangles are also congruent. CP, CTC. Okay, now I'm going to play the rest of the video and let's see how we did, if we came up with the same. Yes? After the lesson's over. Okay, here we go.
Is congruent to angle R.
So she marks them, which is a good thing to start with.
I know that angle 2 is congruent to angle N. Alright? And then the third piece of information, MN is congruent to MR. Alright. I want to prove that KR and NP are indeed congruent. And I can do that if I can justify that these are congruent triangles. However, at this point, I can't say that because I don't even have angles in the two triangles that are congruent. Let's start with just writing down our given information.
I'm going to skip ahead.
Angle 1.
Oops.
I also have that angle 1 is congruent to angle 2 because these are vertical angles.
So we found that, right? Yeah, her angles are kind of crazy.
Alright? So if I do that, that means that angle 2,
Ruben?
angle 1 is also congruent to angle N, which may come in handy. I'm also going to write down the side that I didn't do. And MR is congruent to NN. Also given information. Alright? So now I have that angle 1 is congruent to angle 2. And by the same token, I can say that angle R is congruent to angle N by substitution.
So she says she's just substituting it in, but it's also the transitive property. I like to use transitive property because it's one of our main properties.
Because if 1 is congruent to R and 2 is congruent to N, then R is congruent to N.
Okay, skipping ahead a little bit.
And the reason for that is angle, side, angle.
Is that what we wrote? Angle, side, angle?
And then the sides are congruent, KR,
Did angle, side, angle.
congruent to
Okay? So I think
PN.
we did it pretty well. Just one difference was substitution, but transitive property is also applicable. Okay? So that's the flow chart. Any questions on the flow chart? Okay, I mentioned that there in the essential question that there are 4 different types of ways to set up your proof. The 4 methods. Would you hit those lights? Turn them back on for me, please. Thank you. The 4 methods to prove methods. I don't know. I don't like how I just worded that. Okay. The 4 methods are, the first kind we did with UNO proofs. We mentioned already today what those are called. UNO proofs. How did we format the UNO proof? 2 columns. We have a 2-column proof. And there are 2 L's. Column. Okay, then we did today's was a flowchart. Okay, if you were listening to the video, she actually went over a couple others. Briefly, she just mentioned them. We have a paragraph proof. Okay, you can just explain everything in words, but everything has to go in order. You have to prove it baby step by baby step. You can't just skip around. Once you have one connection, you have to go right on to the next connection. And the last one is a diagram without words. Without words. W/O means without. Without words. Okay? The very last thing we're going to talk about today is the difference between definitions, postulates, and theorems. Okay? Definitions, postulates, and theorems. So we're just going to take your ruler and draw yourself a short 3-column. It'll be wide, but vertically it can be short. 3 columns. The first one is definitions. The middle one, we're going to talk about postulates and theorems. Definitions, postulates, and theorems. You've probably at least heard about definitions for years, right, since elementary school. Can someone define what definitions are? Yeah? Meanings of words, or because you wouldn't really use define in to explain what a definition is, right? We try to get away from using the word to define itself. So a meaning would work, or it explains what the term means. Okay, a definition explains what the term means. Okay? So we learned some of those definitions today. There's tons of definitions. We've done vocabulary before. But for instance, some we've learned today is what an altitude is. I'm not going to write the definition because we've already written that today. We've also done what a median is. And by the way, altitudes and medians are different unless it's constructed on an isosceles triangle or an equilateral triangle. Then they are the same. Then they both are perpendicular and they both intersect at the midpoint. Okay, but if it's not an isosceles or an equilateral, then the median and the altitude are different. Okay, so other things we've talked about, the properties, for instance, the transitive property. And we define that. Okay, postulates. Postulate is a statement assumed true without proof. A statement assumed true without proof. Okay. On your foldable, look at the title, please. What's the third word on the title? What's the third word? Postulate. So all of these triangle congruency things we've gone over are postulates. So examples of postulates. We never actually proved side, side, side. We just assumed it to be true. I gave you a foldable and we said, hey, these are congruency postulates, and accept them as fact. We actually never proved side, angle, or angle, side, angle, or angle, angle, side. But those are all postulates. We accept them to be true. Okay, and the last one is theorems. Theorems are a statement assumed true, a true statement that can be proven. Sorry. A true statement that can be proven. What's a theorem we've proved this year in the past couple weeks? Yeah? Ooh, we didn't prove that, but I bet you proved it last year, but that is a theorem. Pythagorean theorem. Theorem. Other theorems? We've done a theorem about triangles. And we've already mentioned it today. It's about angles of triangles. Oh, Bo? All the angles will add up to 180, right? Yep. And so that's called the triangle angle sum theorem. We actually proved that two different ways. Triangle angle sum theorem. Okay, so differences. Definitions are different than postulates. Postulates are different than theorems, and definitions are different than theorems. Okay, so try to keep those straight. Our homework tonight is a pack